Assalamualaikum. Today I would like to present a mathematical case study. This case study has several parts and my group member has been taken part. The case study, this is my case study report. The title is Electrical Accident Based on 5 States from 2020 and 2017. My lecturer name is Encik Khairul Anwar bin Abdullah. My group members Muhammad Fatul Rahman bin BHARU 04DET20F1090, and my friend is Muhammad Izzuddin Imam bin Daud 04DET20F1008, Wan Ahmad Nazib dan Wan Kamarul Zaman 04DET20F1003, Muhammad Fahmi bin Mazdan 04DET20F1075, Ahmad Nabi bin Muhammad Sobri 04DET20F1039. I want to discuss about the mathematics case study report for the beginning. Electrical safety may be a low probability, high impact subsection of workplace safety. This implies that although electricity related events could also be relatively unlikely to occur, they are of great importance after they do, and also the consequences will be deadly. Thanks to the low likelihood, some organizations ignore or suspend improving their electrical safety plan. Electrical injuries may be the result of direct contact with an energized item, but may happen if someone is nearby when an electrical incident takes place. Light and arc flash both can cause fatal electrocution, electric shock, burns, and falls. This is often why it's important to stay electrical safety in mind, even when a personnel won't necessarily be interacting with an energized item. In many countries, workplaces legally have to develop and implement a written health and safety program that addresses workplace electrical hazard. Consequences for inadequate safety measures can include repossessions like fines and insurance costs. More importantly, the implications for your employers are often much greater: severe injury or maybe death.
Assalamualaikum and hi everyone. My name is Muhammad Izzuddin Aiman bin Daud and my metric number is 04DET20F1008 and I'm from DET3E. So I'm gonna present the case study. The title is Electrical Accident Based on 5 States from 2012 to 2017. So the data below show the number of electrical accidents based on 5 states from 2012 to 2017. Include Sabah, Selangor, Perak, Kedah, Johor, and Yeah. Today I'm gonna construct the frequency table. To construct the frequency table, we must find the number of class. The number of class is, we use the formula 1 plus 3.3.3 log n. So we change the formula to 1 plus 3.3.3 log 30. As we know, 30 is the total of the data that we have. So the answer is 5.918. From 5.918, we round off to 6. So the answer is 6. Next, we must find the class range. So the formula of the class range is range divided by number of class. So the range is 18 minus 0 and divide by 6. So 18 must be the highest value of the data, while the 0 must be lowest value of the data. So the answer is 3. Next, that's from the table you can see that is the example. That is the frequency table from our data. So next, measure of the central tendency and depression, dispersion, mean, median, mode, mean deviation, variation, standard deviation, and percentile. First, mean. To find mean, we must have frequency table, which is number of electrical accidents, frequency, midpoint, and fx. First, we must calculate the total of the frequency. So the answer is 30. Next, we must calculate the total of fx. The answer is 199. So mean, the formula of mean is total of fx divided by total of frequency. So the mean is 199 divided by 30. So the answer is 6.633. Next, we must find the median. Same as the mean, we must use the frequency table, which is the number of electrical accident, frequency, lower and upper boundary, and cumulative frequency. So determine the class which medians lies. So the formula is n, divide by 2. So the n is total of the data that we have. So the calculation is 30 divided by 2, and the answer is 15. So we must find the lower boundaries, lower boundaries, frequency, we must find L, F, FM and C. So the L is the 3.5, while the F is 7, the FM is 11 and C is 3. So based on the data we have, we put into the formula of the median. So L plus in bracket N divide by 2 minus F, and then divide by Fn, and next the answer must be sum to C. So we change the formula into 3.5 plus 30 plus in bracket 30 divide by 2 equals to 7 and divide by 11, and then sum 3. So the answer is 35.5 plus 2.18. So the answer of median is 5.68. Next, we must find mode. So at the same as the previous question, to find mode we must use frequency table. So we must complete the data, which is L, D1, D2 and C. L must be lower boundary, which is 3.5, and then D1 must be frequency, and also D2 must be frequency 2, and C must be 3. So the formula of mode is L plus in bracket D1 divide by D2 plus the formula of mode is L plus in bracket D1 divide by D1 plus D2 and sum by C. So we have 3.5 plus 4 divide by 4 plus 5 and sum by 3. So the answer of mode is 4.83. That's all from me. Thank you, and I will pass to the next person.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Nazif bin Wan Kamaruzaman. Matrix number is 04DET20F1003. I'm here to present my part. My part is mean deviation, variance, standard deviation, and percentile. So first is mean deviation. Mean deviation, the formula is E equals sum of midpoint minus mean of data times frequency divided by sum of frequency. We get 100.78 divided by 30, and we get the answer is 3.36. The next part is variance. Formula is S power of 2 equals sum of midpoint minus mean of data power of 2 times frequency divided by sum of frequency. And we get 525.06 divided by 30, and the answer is 17.50. The next part is standard deviation. The formula is S equals square root of 2 variance, and we get square root of 2 17.50, and the answer is 4.18. And my last part is percentile. The formula is PK equals lower boundary for the measuring class, which is L, plus K times total of frequency N divided by 100 minus cumulative frequency before cumulative for the measuring class, which is F, and divide by frequency for the measuring class, which is F, and times class size, which is C, and we get 6.5 plus 65 times 30 divided by 100 minus 18 divided by 6 times 3, and we go to next step. 6.5 plus 19.5 minus 18 divide by 6 and times 3, and the answer is 7.25. So my part is over, and I will given the next part to Fahmi. Thank you.
Assalamualaikum, my name is Mak Fahmi bin Mazlan from the 83E. So today I want to present about graph histogram and OGIF. This graph is based on 5 states starting 2012 until 2017. So before starting to draw the graph, the first thing to do is build a table and collect data. So this table is show you detail about histogram graph. This frequency is for part CX and midpoint for part CY. So at the frequency at the first year in 2012, we get a 7, and the next year 11 and 6, 2, and the last year at 2017 we have a 2. And the total frequency for the 5 years we get the 30. And the midpoint for part CY at the first year we get 2, and the next year we get 5, 8, 11, 13 and 17. So this graph is show you at the first bar the frequency is 7 and the midpoint is 2, and the next bar the frequency is 11 and the midpoint is 5, and the next year in 2013 the frequency is 6 and midpoint is 8, and another 3 years 2014 until 2017 we have a same frequency. Is it 2, 2 and 2. So this is all about histogram, and we go to OGIF graph. So this graph is show you this cumulative frequency is part Cx and upper boundary is part Cy. So the cumulative frequency is 7, so we get this point, and upper boundary we get 3.5. So this point is for 2012, and the next year cumulative frequency for 2013 is 18. So this point at here you can see here, and upper boundary we get 6.5, and then the next year is the cumulative frequency for 2013 we get 24, and upper boundary we get 9.5. Sorry. So this point at here. So, and the next year the cumulative frequency is 26. So upper boundary we get 12.5. So this point at here, and the next year the cumulative frequency is 28, and upper boundary we have 15.5. And the last year we get a cumulative frequency for 2017 is cumulative frequency is 30, and the upper boundary we get 18.5.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad BHARU and number register is 04DET20F1039, and today I'm gonna talk about a case study, and I'm gonna talk about topic statistic, and I'm gonna talk about question about the question is it sound like a measure a quartile and decide using graph. So we can see I got this graph. This is my graph and my members do it, and I'm gonna talk about how to measure a quartile. Okay, formula for to measure a quartile is 1 times NTH divided by 4. Okay, kita got 1 lah, and N we got a 13 TH divided by 4, we got a 0, we got, and the answer we got a 7.5 TH, and we got question and quartile 1 we got a 3.6. Okay, so this is a quartile 1. For a quartile 3 is for quartile 3 we're gonna use the formula for quartile 3 is 3 times with n th divided by 4, and we got a 22.5 th, and quartile 3 and 30.5 th. We're gonna easy it, and the answer is quartile 3 is 9. Okay, this side formula for this side is LDK add and times with kn divided by 10 and tolak f and divided by fdk times with c, and ldk is 1, and kn we got kn we got 18 tolak 15 tolak 15 divided by 16 and times with 5, and the answer we got 30.47, and the answer we got is 30.47375. The answer we gonna this. Okay, thank you for me. And that's all for me. Thank you very much.
And for the conclusion, electrical accident is one simple phenomenon and isn't perfectly understood. The bulk of electrical accidents occur at the common domestic and commercial electricity supply voltage, i.e. 230 and 400 volts. And a high proportion of electrical accidents are serious or fatal. Artificial resuscitation for persons unconscious after a shock is effective and may be continue for a minimum of 1 hour or until hospitalization. Electrical burns may cause death in extreme case where they are extensive. In other cases, however, although they will be deep, they are largely sterile and thus tend to heal quickly and well. Although they will leave scar, damage to muscle could also be serious, and amputation is also necessary in very bad case. Attention should be paid to small burns caused by contact with high voltage conductor because there could also be serious deep seated damage, neurosis, which isn't visible. Thank you.